Hello, everyone, and welcome to this day 2 of our virtual summit 2023. And I hope you've been enjoying the last couple of days. I'm sure you've learned a lot, and I certainly have learned quite a few things from the recent sessions that we've had on this virtual summit. I'm pleased today to have on this session with me Gareth McLaughlin, who is CTO of Connectio. Gareth, do you want to just introduce yourself?
Hi guys, my name's Gareth McLaughlin and I'm the CTO for Connectio. We are an IoT company who utilise device authority services for security around our Edge and IoT platform, and I'll go into a bit more detail around that on the slides.
Brilliant. Thank you, Gareth. And for this session today, Gareth, we've taken you through a journey to discuss utilizing IoT insight for your supply chain. And I guess that sounds like an interesting topic for us, certainly around the topics of today, given what's happening in the world. And
Yeah.
we certainly get involved a lot around supply chain activities. Well, without more further ado, then, Gareth, I will hand the floor over to you and let you take the audience.
Thank you very much. Thank you.
No worries.
Hey guys, so I'll just hopefully you all see these slides okay. So yeah, supply chain and utilizing IoT for that insight. So how does IoT help organizations drive efficiency and insightful decision making for their supply chain? So as I've elaborated, I work for Connectio and we utilize device authority currently for all of our security around our Edge and IoT devices. So I am from the north of Ireland. I currently work for Connectio, who are IoT specialists, as I've mentioned. So we would monitor wages, which is water, air, gas, electric, and steam. And we also monitor the likes of vibration and perform predictive analysis on large quarry crushing machines and hydraulic machines that would crush cars and press cars for predictive alerts, as well as the energy consumption and also water consumption for quite a lot of our water utilities companies in the UK and Europe. Before this year, I worked for JCB Wrightbus, and I built the world's first hydrogen telematics solution, which is now used across Europe and other parts of the world to monitor the diesel, electric, and also the hydrogen buses that you'll start to see driving around cities. And I also assisted in building and enabling smart factories for food industries, £1 billion companies. So I've been working about 25 years now in the IT industry. And that's a QR code. I'll show you that at the end as well. That's just a QR code for my LinkedIn profile. If any of you would want to make contact through LinkedIn, just take a screen grab of that now, or as I've said, you'll be able to get that at the end. Supply chain management. So we are all probably familiar of what supply chain is. However, I'll just go into a bit more detail on it. So supply chain starts right at the raw material, wheat fields and farming, and makes its way through to the supplier. And that can be the wheat field or the farmers themselves supplying. And then the manufacturing process, that can be anything from like bus manufacturing to manufacturing of food products, your mobile phones and all of that. And then the distribution service, logistics, your Amazon vans and everything, your Royal Mails, DHL, they're all taking care of that logistical service today. And then retail locations, so all of your shops and supermarkets and everything that is part of your supply chain. And the consumer and customer is also part of that supply chain. So each of these stages have problems which impact companies' efficiencies and fundamentally impact the bottom line through insight and lack of insight and lack of transparency and issues that are raised throughout that full supply chain life cycle. And we're all familiar with each of these stages, and we all are currently involved in most of these stages within our business processes and our day-to-day life. So first of all, understanding supply chain. A supply chain is a network of all individuals, organizations, resources, activities, and technologies involved in the creation and sale of a product. A supply chain encompasses everything from the delivery of source material from the supplier to the manufacturer through to its eventful delivery to the end user. And the supply chain segment involved with getting the finished product to the manufacturer, to the customer, is known as the distribution channel. So steps in the supply chain. The fundamental steps of a supply chain in order are as follows. So sourcing of that raw material, so the agricultural process or the metal fab process. Refining those materials into basic parts, so that's the processing element. Combining those basic parts to create a product, i.e. manufacturing. Order fulfillment and sales is actually a combination of manufacturing and also the product delivery, which is logistics. And then finally, customer and consumer support and return services and insight after it's sold is your telematics and data flow insight. So supply chain challenges today. Modern supply chains are complex and present several common challenges, and these are like potential lack of transparency, which is a major issue for most of us today. Lost or delayed goods get to that process, which impacts your manufacturing process because they're not there to make the final product. Increasing customer expectations. So new technology and businesses raise customer expectation, which can be difficult to manage and impossible to meet if not properly managed. And you can only manage it through IoT, and IoT gives you that level of insight. And resiliency to sudden changes in supply chain. External factors can cause unforeseen changes in supply chain. So best practice is to prepare for the unexpected and to be able to pivot if need be. So will all be familiar with two of the most recent fundamental issues that has caused massive delay and disruption to supply chain. The first one was COVID, and that has impacted and touched absolutely every one of us. So Ernst & Young have done a report on the impact of it, and what has come out of the back of that is that digitization is now a massive requirement. So before digitization, we would have been looking at the likes of ESG was a real important requirement for customers. The actual stage now is that it's not ESG is the requirement. It's the priority now is actually getting insight into that supply chain. Number 3 there, increased visibility. That there is what IoT will help with, and that's what is a shift now. And actually the next thing, so outside of COVID, one of the other things that impacted the supply chain was the Suez Canal. So this here actually happened on I think it was the 21st of March 21, no, the 23rd of March 21. And within 5 days, this ship that got stuck on the Suez Canal actually impacted 300 large cargo ships that were held up that were destined for Europe. That affected 16.9 million tons or 37 billion pounds worth of dead weight material that was on the ships that was buffered in behind that ship. So that had a massive impact in the supply chain. I know whenever I was working for Wrightbus, JCB at the time, that impacted us massively because we had the EV batteries that were coming from parts of China and other areas, as well as seats that were coming from Turkey. They were all stuck and impacted by that. So what we actually had to do was diversify and segment our suppliers out of the back of that. And we used IoT technology to move away from using water at that stage and actually using land as our logistical service to get those seats and those batteries to us. So we used IoT to give us insight into the locations of those. Understanding IoT. So this is actually a very important slide because I have been involved in quite a lot of IoT technologies over the last few years that has given insight utilizing IoT to different sectors. So if we start at the bottom there, IoT enabled cities. So environmental sensors are now on most buildings and actually on the back of buses now that is monitoring the pollutants and levels of noise within cities. So we're all trying to get greener and more environmentally friendly. And IoT is actually driving that level of insight through data. In addition to that, their waste garbage collection, they're now utilizing bin sensors to detect how full bins are so that they can say that certain garbage collection trucks don't need to go up certain routes because the bins are not needed, commercial bins are not full, therefore wasted travel is reduced massively. In addition to that, there you see a small icon of a bridge. There's stress test gauges now in a lot of vehicle bridges, as well as footfall bridges that can monitor the footfall, how many vehicles is passing over a bridge, but also detect flex in that bridge. And those IoT sensors are every day sending information back to headquarters to monitor predictive issues with bridges and failing points. And that again is done through data flow and cellular connectivity. Ships, so we're now utilising IoT technology to monitor people and assets within ships, so large cruise liners, etc. On IoT enabled factories, so factory stores, stock levels, and the movement of stock to factory floor detection. So ensuring that all of that stock that comes in from your supply chain comes into your stores. You're using the likes of this here, and hopefully you see me okay, but this here is an RFID tag, very low cost, they're 2 or 3 pence each. And we're sticking those there to a lot of our high value items that comes into your stock. Once that comes in, there's overhead RFID readers and antennas will be able to detect all products that they are on to ensure that we can monitor the flow of those materials in stock, how long they're in stock, and whenever they actually leave our stock areas and go into the manufacturing process, it can see where it's sitting within our factory floors and how long it has been there. So that has given that full control. As well as that, within our factories, we're now able to monitor the right labour to line. So we're putting trackers onto staff to, one, monitor them from a health and safety perspective, i.e. lone worker, but also ensuring that we have the right amount of labour to the right lines. Therefore, we're very efficient in how we work. As well as that, energy and water consumption is now monitored via IoT to ensure that we're driving more efficiency, and we're also monitoring our effluent discharge out into the rivers at the right time, i.e. we can't do effluent discharge whenever river levels are low because we don't have the water to take it away. And so IoT technology can monitor the valves and only open them when water levels are high. And again, I've been involved in a project like that there, and that is IoT driving that level of insight, and SCADA systems is operating those machines. IoT shops. So we have all went into supermarkets and shops and stores, and we've seen the future of shops and all. So whenever you go into shops and supermarkets and stores, there is footfall cameras that are monitoring our movement, and they can use your mobile device. So the IMEI of your mobile device will actually see whenever you've come into a shop, and it'll actually know whether or not you've been in that shop before and how long you have spent there and what your journey is. It'll also use that for marketing material. So you'll start to see digitized billboards whenever you start to enter a shopping centre to say, nice to see you again. We noticed the last time you went to Costa Coffee. How's about having a free voucher on us? Scan this QR code. And it's making that shopping experience more immersive, but it's also supplying that data intelligence and that machine learning to the supermarkets and supply chains to ensure that they have the right products for the right people there at all times. So that's a massive thing that we're starting to see a shift in. And then with regards to IoT enabled mobile devices, we're all very familiar with our mobile phones. Mobile phones now come with GPS locations on them. You can find your phone. You've got your shock detection. You've got accelerometers and all built into mobile phones today. So without really knowing it, we're all using IoT devices. And also within your home, we all have seen a major rise in the amount of IoT enabled devices that we use at home to manage heating and also manage our supply chain. So we've seen smart fridges, and them smart fridges can detect when certain products come to an end. It'll automatically order it and actually drive the whole logistical service to ensure that they're replenished, that stock was replenished without you having to actually do anything. So we're seeing a massive shift in that. So what impact of having IoT in the entire supply chain? The IoT enables closer collaboration between the suppliers and the manufacturers by providing real-time visibility into supplier performance, inventory levels, production schedules. And by sharing data, companies can optimize their supply chain processes and lead times and improve quality. So understanding IoT. So the Internet of Things describes physical objects with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the internet and other communication networks. So With regards to assets, that can be large, like I said, quarry crushing machines, it can be vehicles themselves, it can be people, it can be packaging machines, or it can be consumable products, i.e. food, your steaks and stuff that you would get at Marks and Spencer's and your Sainsbury's and all now have a level of tagging on them that are IoT enabled now. Those assets can and will have sensors and sensor capabilities on it. So like footfall cameras, we have footfall cameras now in universities that can detect how many students are attending classes. And if they're not attending classes, we have smart theatres now with lighting built into it. We have counters there that can actually do the footfall counters for all of the people that would go onto those things as well. We can do GPS locating and tracking and tracing. So this here is an asset tracker that I have in front of me. It's quite a large one. This is actually for vehicle tracking. And fundamentally, this here has within it a couple of high-powered AA batteries specific for IoT devices. This has got a cellular tracker on it, SIM connectivity, temperature sensors, as well as humidity sensors. So this here device is being used to track certain products that's out there now. So we have them on vehicle trackers, but we also can put them into medical bags, which I'll elaborate on a bit further. These here can track and also monitor the temperature, shock detection of all assets at all times. As well as that, you've got humidity, vibration sensors, light sensors, and also vehicles, as we know, can be monitored via their CAN network. All of those sensors are only good if you can connect, and there's different levels of connecting. So we all know about the 3G, 4G, 5G network. There's now a new one that's going to be coming out utilizing the 5G network called O-RAN. We've got Sigfox connectivity, which is used to connect IoT devices. LoRaWAN will be one that would be as a private network that would be used for large mining industries with 14-kilometer radius, and you can connect all of those devices through one gateway and post all of that information out on vehicles, people, and all of the tools that will be on site. BLE, so we all know what Bluetooth are. My headphones are Bluetooth enabled. The mobile phones are Bluetooth enabled. This here is a small active Bluetooth enabled device. And what this does, it has a small battery within it, and this has got a 3 to 7 year battery life, depending on how often you send the signal out. This here we are using within hospitals to monitor the location of all hospital beds, wheelchairs, gas cylinders and all. And this here will send a signal up to HP or Cisco or other Bluetooth enabled readers on the exact location and the exact movement of assets. As well as that, you get these iBeacon sensors with small humidity and temperature sensors in them. And the reason why they're important is there's a lot of hospitals and other industries that will store equipment like beds and mattresses away. And some of the special needs mattresses are about £3,000 each. And whenever they're stored away for a long time, they can become blue molded because the storage conditions are not optimal, and therefore there's waste and inefficiency there. So we use those sensors there to monitor those beds and the storage conditions that they're in, and let the hospitals know that they need to do something about the conditions, or put a heater in, or get the mattresses out of those places as well. So it's giving them that level of insight, and it's very cheap to do so. And other connectivity messages and protocols are NB-IoT and LTE mobile for the American network. And then all of that connectivity is only good if you can actually make use of it. So software and data layer. So we've all seen the visualization. So we've got map view showing things moving about and the RAG status of those pieces of equipment. So red, amber, green, giving you the health status of all of those assets. We can perform analytics, so AI and machine learning on that there. So an example would be within our telematics solution that we've done for Wrightbus JCB. We were able to detect that we were consuming about 7% of the battery on the EV products before they even started to move that morning. And using machine learning, we were able to detect that it was actually the bus drivers were going in and heating up the buses in the winter mornings, and they were turning that bus from being around 2 degrees to about 19 degrees. And during that heat up phase, it was consuming the cell packs, the energy that was on board that bus, therefore reducing the distance that bus could travel in the day. So the machine learning protocol and using AI were able to say, heat the bus up while the buses were still plugged into the grid. Consuming electric off the grid was more cost effective and actually allowed the vehicles to go out and perform better during the day. That level of insight is now driving the next level, which is automatic preconditioning. So the vehicles, whilst they're plugged into the grid, will know that they're going out into service that day. So they will precondition before anyone goes near that bus. So no human interaction is required. BA reporting, so we're all used at board level and reporting operational level on the level of reporting, and you can only do that through insight. And that's where the intelligence really come. Data is one thing, but insightful data is what drives that decision making. Workflows themselves, so a workflow will know, like I know I have consumed items from a store, and whenever I've consumed that item from a store, therefore the system orders more. And that's an example of the workflow that we have in place. Another one, like I was mentioning earlier on, because of that Suez Canal blockage, I know whenever I was bringing items via land and logistical lorries, I know whenever certain items got to dry docks because I could see the GPS locations of them, I could predict the speed that was doing, and I knew whenever it was going to get to a certain area, we could actually order and automatically arrange logistical pickup to then enable that transition from one dry dock across into another van and keep that flow going. And an example of alerting. So we have helped organizations in the past on train lines where they would have had lone workers. And whenever you have lone workers, you need to ensure their safety at all times. So we would have used devices very similar to this one. Actually, it's a similar size to the mobile phone. And what it done was it was able to monitor the temperatures and the movement of lone workers on those train lines. But it also had shock and G-force detection built into it, as well as heart monitors. So whenever that sensor detected that it was in this position and detected a G-force, we detected a fall. And what it would have done, it would have vibrated that sensor to say, please let me know you're okay. And they had green and red. So green meant, yes, I'm okay. You don't need to do anything. I'm actually just working. And, oh, sorry, I'm not sure what's happened there. 1 second, sorry. Yeah, sorry. And it was able to detect that there and send that alert to say if they'd hit the red button that they needed some level of help, or if they hit no buttons at all, it's still triggered to say there's been a fall and we need alert. So that is how we utilised alerting protocols off the back of those sensors to give that insight. So IoT capabilities, so it's the right assets at the right place, at the right time, in the right condition. So I've already mentioned the likes of these here, RFID tags, and they are very low cost. So if you have high volume items, they are the perfect thing to complement your IoT insight. We also have the indoor and outdoor in transit locating, so the likes of GPS, using Wi-Fi, Bluetooth, cellular, satellite signals. They're a very good thing to give you a level of detail and insight into your assets. And RTLS, so real-time locating, sensing and services. This is this here. So if you have RTLS enabled in your massive factories and your hospitals with multiple floors, you'll be able to say within a few feet or even down to the levels of a few inches of the location of the assets that those are located to, as well as the temperatures. So that's given a level of insight that was never there before. So IoT within the agricultural sector. So we've all been to vineyards, and if you've been to a vineyard before, you'll have seen at the end of each of the vineyard lines, there's roses and there's flowers planted there. The reason for those goes back in history, but flowers actually detect pollutants and disease before the vineyards and the vines actually detect them. So it's an early detection system that was there for hundreds of years. And IoT has now replaced that. So instead of the farmer going out and seeing that there's a small bit of disease occurring on a rose and therefore spraying the vines to ensure that they don't get that disease, there's IoT sensors now being enabled in vineyards that will detect pollutants and air conditions as well as soil conditions, and send those alerts back to a central area to enable the vineyard managers and farmers to take action and to enable, I suppose, better quality products and less field products. Wheat field and disease heat monitoring via drones. So in Australia, they're now using drones to go out and detect anomalies within the wheat fields. And these wheat fields in Australia are hundreds of miles in diameter. So the drones are going out and detecting I suppose, the differences in heat coming off the wheat, and they're able to kind of ring fence areas of disease and actually contain that disease before it spreads. And also within the food chain, we've all seen milk cows that all have those RFID and NFC tags hanging from them. Those tags contain information on those cows and how much it eats, how often it's actually at the water trough, and what the temperature is of where that cow is, as well as the temperature of the actual cow itself. And this feeds information back to smart parlours, so whenever they're coming in for milk, we know how much milk to detect from them, and also if there's potential disease and potential medical issues with that cow, i.e. it hasn't ate or it hasn't went to the water trough, we know there's issues with that there. That information is also feeding into what we know today as the farm to fork supply and food chain. So we can get right down to the farmer, know how that cow has been treated, know how much medical information and treatment it has had throughout its life, and that feeds right through to the farm to fork process. I have eggs and farms right down there. So I was recently involved in a project where we used IoT sensors to monitor the factories for hen and duck eggs. And the reason why we're using that there is because temperature has a massive impact on how they lay eggs, and as well as that, light has an impact. So the light needs to be on at a certain time, and needs to ensure it's off at night. So we use IoT to give a level of insight to those farmers to say the temperature is right or it's wrong, and also that the lights are left on at night, therefore they will not lay eggs. As well as that, we're using the sensors to detect water consumption, water pollutants, as well as contaminants within the air within those factories. So early prevention is key for those farmers. Before that, they would have a massive waste of either the hens and ducks themselves, but as well as that, a low yield on the eggs that was deployed. So they've seen a massive increase in that. Finally, fueling. So in Australia, the outback, and also in US and Canada, they would have massive fuel tankers that would go out at night whenever they're not operational to fuel up those vehicles. And before IoT and GPS locating, those vehicles would have went out into the 100 miles, 200-300 mile radius mining and farming locations to try and find those vehicles that they would have had to refueled. Now they get insight into whether or not the vehicle does need refuel, because we get that insight off the CAN network. But also they're able to see the exact location of that vehicle and what needs to be done. In addition to fueling, they're also able to see if vehicles out there during the day have a potential issue occurring on it, i.e. oil pressure, water temperatures, brake pads, etc. And that information all feeds back to the servicing team, so that we know we can send the servicing team out to the right place at the right time to ensure uptime and optimal performance within that sector. Manufacturing logistics. So manufacturing, I've elaborated on a few points here, but there's high value, high impact BOM items required there. So if you're involved in the manufacturing process, you rely heavily on your supply chain. Supply chain has a massive impact. And lean manufacturing is a massive piece. So you don't want to hold up too much stock, because that impacts your bottom line. And holding stock increases your buffer count, and it's just very inefficient. So you want to run lean manufacturing and have products delivered just in time. So the Suez Canal impact had a massive impact in us, and I'm sure a lot of organizations. And we needed to ensure that what we were getting delivered was right. So say, for example, on these large EV buses, the cell packs are very expensive products that we were buying in. Whenever they left the supplier, we monitored the location and the storage temperatures of those EV batteries, as well as shock detection. So we are able to ensure that whenever that EV cell packs or those EV cell packs got to your premises and into your store, that during that transition and that logistical journey, that they followed the process for warranty reasons. We were able to kind of comply to that there as well. So that gives a level of insight that was never there before. As well as that, we're able to actually do smart stock management now, again, using the likes of these RFID tags to monitor all assets that is within our stores. And whenever they actually leave the stores and go into our manufacturing process, we're able to say that that has now left the store and replenish the stock. And that, again, instead of it being manual stock tech and stock counts, that level of RFID and IoT in our supply chain cycle gives that level of insight and smart stock management. So that is seeing a massive shift in the manufacturing process. And this is how RFID tags fundamentally help with that there. So we're binding tags to different products, and in that product bin or the bin counter, we can see how many of them products there is, and whenever they're replenished and whenever they're actually consumed using the FIFO model, those products follow our whole process. They go through quality check, they get applied to an end product during the manufacturing process, and then the finished product make its way out to be consumed by the end user. So those finished products are then picked up, and those RFID tags are then put in the recycling bin because of the cost of them. But that gives a level of insight of, I suppose, that manufacturing process right through from the warehouse, stock control, product build, paint shop, quality control, through to sales. Medical insight. So whenever COVID hit, we had to give a level of insight into, I suppose, those highly important critical sectors that is there. So we monitored staff. So there was critical staff that had to continue to work within hospitals. Those critical staff, we needed to ensure that we could see who they were talking to and how often they were near other members of staff to reduce the potential flow of COVID and the outbreak. So IoT give that level of insight, and actually most people then become familiar with that app that we all had to get, and that was able to detect whenever we were near other people, so that if we became positive, it was able to alert other people to say you were in close contact with people. Again, that was IoT that gave that level of insight. When it comes to efficiencies and insight, we are using, like I have mentioned, Bluetooth and RFID tags to detect the movement of wheelchairs, beds, as well as gas cylinders and drugs. And that has actually enabled staff to be, I suppose, it unburdens staff and gives them more efficiency. So what we had found within the NHS is 20% of staff's time was spent looking for things to allow them to do their job. And that could be temperature probes, that could be the gas cylinders, that could be beds and different medical equipment. So using IoT and sensors and RFID tags, and also infrastructure that was in the hospitals, that was able to give us a level of insight that was never there before. In addition to that, gas cylinders have a life expectancy. And until they're, the life expectancy is the gas within them has to be used within 1 month or 3 months, depending on the types of gas. And IoT now monitors the service date, the replenish date, the location of those, and when they need to be regassed. And some of these gas cylinders go out into community. And in the past, whenever they went out into the community, we just lost insight into how long they've been out there and what is being used and how it's being used and where it's at. Now we know where they're at, and now we know how we get them recalled in. This picture here is actually showing a company that makes medical surgical equipment for all knee and hip replacements across the UK and Ireland. This company provides a distribution service for most of the NHS and private sectors. So if you know anyone that has ever had a knee or a hip replacement, it's been this company that's most probably supplied the equipment for that. Within these blue boxes, you could have about 120 to 480 small items within boxes. And what this company does is, behind those doors there, this company actually builds those boxes up and closes them and sends them out ready for distribution. So a person would manually build those boxes up based on the requirements: right knee, left knee, right hip, left hip, etc. Whenever it passes through that door, there's an RFID tag on every single item that's within that blue box. And there's a reader above that door, and it detects and just validates that all items that should be within that box is actually there. And if it's not, it sends an alert, and they can actually replenish and ensure that there's the right stock on that before it goes out into service. Whenever those boxes go to the hospitals to be consumed, they don't consume all the products during that surgery. They'll consume a certain amount. And whenever they do consume it, they'll close the box, they'll cable tie that box up and send it back to this company to again replenish. In the past, those blue boxes would have come in and someone manually would have opened them up and counted everything and actually tried to figure out in the middle of those 480 items what was missing to replenish. Now, whenever the van drivers drop them off at this here location again for returns, there's an overhead reader will detect the presence of that box and actually feed into their ERP system to say that this box has been returned and here is the X amount of items that needs to be replenished. No counting, no human interaction is now required apart from just replenishing what it tells you to replenish. So that has a massive impact in efficiency and accuracy for that company. And I'm not sure if we're all familiar with this bag, but I'm sure we've seen it in films and the ambulance programs that are on. But this is a pathology bag, and it's a critical piece of equipment for what is going on now across the globe. So we'll see motorbike riders will move hearts and hearts for critical patients across the UK and Ireland, and we give a level of insight to the location of those bags, the temperature of them, how they're being treated during transport, if they've been dropped, as well as the temperature of all equipment, organs, hearts, bloods within those bags at all times. An issue in Belfast near me is that there is 2 departments within the hospital in Northern Ireland here in Belfast, and there's 2 departments called pathology. And sometimes it's not the NHS's own logistical people that they're using to move these things about. It can actually be taxi services are used to transport them. And those taxi firms would just leave them off at what they see as pathology, and it's actually end up at the wrong pathology department. Therefore, it's not getting to the lab in time and has had a massive issue in the past. Therefore, these types of things are now, it's a smaller version of this, is now inside every one of those bags, giving them a level of insight that they need to actually make that accuracy and transparency that they need. Supply chain flow. So this is actually a service that we and I've been involved in the past for fit outs. So we've all seen those massive multi-million pound and £1 billion cruise liners. Those cruise liners will have a life expectancy of 6 to 9 years before they go back into dry docks to get what we would call polished up and get value added to them. So whenever they're in the dry docks from, I think they're 4 to 9 weeks, they'll be in dry docks. What the owners of those ships will do is try and add as much value to that ship as possible. That is, add as many high value material items and pieces of equipment to that ship, chandeliers, wardrobes, fit out all the rooms and everything in that amount of time. So this company would be able and now have the insight into all of their warehouses across Europe, all the shipping containers, the location of those containers at all times, whenever they get to the docks, when they arrive there, whenever they start to onboard all assets and put them onto the ships, where the assets are in those ships for fit out, as well as that they have a labour issue, or they had a labour issue. So at the back of the ship for fit out, they could have had 4,000 assets needing fit it, and in the front of the ship, 1,000 assets. In the past, they wouldn't have knew where to put the right labour to the right areas. Now, because they know the amount of assets that needs to be fitted to those ships in the certain areas, they can ensure that the staff that live on board during this fit out phase are in the right places at the right time. That IoT infrastructure can then stay on board that ship, that gives the ship owners then that visibility of staff movement using the likes of this, which this is actually an NFC card. So whenever you go to do your contactless payment and everything, that's NFC. So they can now use the likes of this here NFC card to swipe into certain areas, gives them visibility of where they're at, as well as those large food containers, the movement of all food on ships at all times. So that is IoT enabled. And the two small clouds here, that is literally the antennas outside the ships that's posting that information up to all of the food suppliers and logistical services that would operate for all those ships. So those ships that would go around the Caribbean and have some drop-off areas and some pick-up areas, they'll pick up food throughout that whole process. And actually, before they go to pick up those foods, this here level of IoT has given those people the insight into what food needs to be replenished. And that couldn't be done without IoT. IoT workforce. So how many and where? So workforce labour insight and protection for lone workers is paramount and very important now. So to the right, we've highlighted the level of accuracy we can get from monitoring. So for example, within the mining workforce in Australia and America, for example, devices are used in this instance to monitor the location of staff, as well as that the accelerometers are built into those monitors. So where the staff are at, if they have fallen, if there's shock detection, and also the temperature of the environment that those staff are working in. Not only staff, but also the assets and the machines in those places as well. And there is equipment, like I mentioned earlier on, that is used for personnel that has SOS buttons built into them. And they can press those SOS buttons to send an alert back to the HQ to say that something needs done. So here you can see the level of accuracy you can get. So GPS is very much dependent on cell towers. So we all know that we can actually find your phone, and that has a level of accuracy to 50 to 30 meters. BLE, Bluetooth, depending on how you have your infrastructure, has a level of accuracy less than 25 meters, or RTLS there, which you have on the right-hand side, is based on the Cisco or HP RTLS infrastructure. If you have enough readers in place, you can get down to a level of accuracy of 20 centimeters right down there. You can get down to about 10 centimeters accuracy. Wi-Fi has a level of accuracy of 15 to 700 meters that can be used within stores in the manufacturing process. And then network triangulation, which is used for the likes of radar and the defence sector for missiles, and that they have a level of accuracy for 1 to 3 kilometers. So there's different connectivity methods that is there. And finally, security. And this is where device authority comes into for myself in the current organisation, but in previous organisations. We can't do any of this level of connectivity. There's so many different devices that we can have connecting to the one platform. And the only way that we can ensure that level of security is through device authority and their key scaler, or key scaler as a service solution. And how does that work? So every one of these devices, if they communicate through a gateway, that gateway has an IoT device, and that device does a registration and authentication to the key scaler service. And then that says, I'm going to validate you and what policies are applied to it. So what level of authority do you have and what access should you have to? And then that creates a certificate to that device, which means that device, every time it comes online, it goes, yes, I know you're okay. You've got a certificate, which I've given you. You can come online and transfer data. And that gives a level of, I suppose, scalability, which we need nowadays, because we have some customers that could have 1,000 assets, and then within 3 months, they'll want 5,000 assets. And to be able to scale up and meet their needs, Keyscaler does that because it's quite automated. So that allows us to scale as a business and actually give that level of insight and, I suppose, confidence to the customers today. And that is me finished for now. So that's 45 minutes. I've done quite well. I'm not sure if I can open the floor up for any questions. Just waiting on a question here from Louise.
Hi, Gary. We have one question that's just come through.
Yes.
How do cyber criminals manage to infiltrate and create intrusions in the complex supply chain landscape, particularly with the utilisation of IoT devices, and what are the resulting impacts on the affected companies? The question does continue. What is the motivation for them to, say, compromise a tractor or heat sensor or heat delivery on a motorbike?
Yes, look, there has been a massive amount of, I suppose, cyber criminals out there at the minute. They're either out there just to disrupt the supply chain. You know, we've seen the likes of, you know, Russia trying to disrupt American supply chain recently there, and they continue to do that. We've seen China trying to disrupt other manufacturers whenever it comes to the electrical supply, and also there's always a motive behind it. And I suppose you can only really try and guarantee the level of security that you need. And you know, Keyscaler and Device Authority give us that level of, I suppose, security that you do need. So there's lots of companies that would rely on a level of encryption, you know, and a password key. But through time, they're easy to get. You know, people can do DDoS, you know, hacks on a lot of these devices out there now, especially over Bluetooth, and infiltrate the messages. So whenever it comes to the likes of cellular communication, Keyscaler is one of the things that allows you to protect that there. There is a levels of, I suppose, cyber criminals that are using localized infiltration. So Bluetooth, if you're close enough to a Bluetooth device, you can actually sniff and listen to the types of messages that they're passing before your gateways pass it up. And that is a level of insight that can actually give some criminals information that they need. And actually, one of the motives behind this here isn't to disrupt service, it's to get data. And if they get a level of data that they feel is GDPR risk, they will actually hold you to ransom and say, we are going to release this data based on your food chain information or your supply chain information unless you pay us a sum of money. And actually what has been noticed is a lot of companies stay very quiet about that because, you know, it's bad for their image. So they will actually end up paying the ransom attacks. And that has happened so many times in the past through ransomware. So yes, it's an ever-changing landscape. There's a lot of money to be made for hackers out there. There's people being paid to be hackers on the dark web and that. So it's always going to be there. I suppose what you need to do is ensure that the companies that you utilize, the likes of, you know, Device Authority and Keyscaler, stay evolving and stay ahead of the times. Because if you don't, the people out there will always try and stay one step ahead of you.
That's the thing, like accessing an IoT device isn't necessarily about getting, you know, control of a piece of equipment. It's actually about getting the data from the rest of the network, because once you're in and you have access, the actual IoT network can provide that lateral movement that you need to get through the rest of the, to get to the piece of the information that you're interested in. So
Yes.
Yeah, that's a brilliant answer. Thank you so much, Gareth.
Yeah, no problem. Yes.
That was our only question for the session. So I'd just like to thank you so much for taking the time to present today.
No, thank you.
Great to have you with us.
Thank you very much, everybody.
Thank you. Goodbye.
Thank you now. Bye-bye. Bye.